So let's take a look at problem 66 here. It says the region D bounded by x equals y squared minus 1 and x equals square root of 1 minus y squared as given in the following figure. So when I look at this problem here, the question I asked in the last video is, do I have a clear upper and lower function? Now when I look at this problem here, when I think of that upper and lower, I say is the one function, so this is the one function here, is that above the other function on the whole interval from -1 to 1. And I would say this one is not. And the reason why I say that is because I have all of this in here that I'm actually looking at. And this function, if you think of it that way, is actually above itself, which is a really weird idea. So that tells me right away that I'm not going to want to use the same process I used in the last video. And what I mean by that is I'm just going to go back to it for a second. I want you to see this. So this is how we did the last one. So we ended up taking the dy first here. And we took the dy first because we realized, hey, we have this function here, which is above the other function across the whole value of 0 to 1 on x. And when I look at this scenario here, it's not the case. I don't have a clear upper and lower function that I can see here. Now, there's another idea we use here to determine how that works. Now, what I'm going to do here is I'm going to actually talk about inverse functions for a minute. I want you to see something here. So there's my y equals x line. And if you don't remember, inverses reflect across the y equals x line. Maybe I should write that a little bit more precisely so I can get a really good inverse here. So now I have this y equals x line, and if I reflect my orange graph, which is this one here, across the y equals x line, and that's what an inverse is. And when I do my change of bounds, that's what I'm actually dealing with here. So what happens is this piece over here maps over here because that distance is the same. And this piece here stays there. So what happens is when these two pieces here swap, it actually creates the same piece of the graph. And when I deal with this piece here, this is going to flip across on this side here. So it's going to fill all of this in. So now this purple graph would be the orange graph that we used to see. Now we're going to graph the other function. That's this sideways parabola here, that x equals -1 plus y squared. Now, if I was to do the same thing with that, this one's going to be a little more strange. Now, this piece right here is going to mimic itself to be right here. And if you draw it all, you'll kind of see how it's going to create like a little lump there. So it's going to go down, and from down, it goes back up and back to there. Okay, so you can see where that goes. And when I look at this piece here, this piece is now going to be on the other side. Now notice it starts at -1 and goes to 1 here. So that means it's going to do this. Oops. This here. And that's going to be this piece. But if you think about the way it looks, it's going to look a little straighter and curve more at the bottom. Okay, because you want these to be the same distance all the way across. Okay, so now the next part then, if I was to draw that and continue to draw that, now this here, let me just finish this one piece here so you can see this. This piece right here would have been this piece right here when I reflected across. So what we end up with is, so this is what it would be. So the red one would be the blue one we used to have here. So this would actually be the parabola. And remember, you swap your domain and range. So that's going to be my y, that's going to be my x now. But what I want you to see from this purple and red one now, if I went from -1 to 1 here, and everything in between, I would have a clear upper function. And that clear upper function would be the orange function that we see down here. So it would be that function there. So, and the lower function on that whole interval from y, from -1 to 1, would be the red one here. That would be all of this. Now on that interval from -1 to 1, that would be the blue function here. So that one would be the function that would be the lower function. So this here then would be my upper bound. Let me do it in the right color as well. So that would be my upper function. And this one here would be my lower function. Now what I'm going to do is I'm going to erase all this madness because I want you to see the originals again, because I want to make a claim here. And I think this will help now. You don't ever have to do this again, but I kind of wanted to show you the reasoning why it works the way it works. So take a look at this when I do that reflection of why I do have a clear upper and lower function. So let's take a look at the original again. So then what I would tell you would be the further right function is going to be the upper function. So this function here, which was actually our upper function here, I'll use the right color, I was using the purple before. That function there is further right than the other function on the whole interval from -1 to 1. So that tells me there that that is going to be the upper function or upper bound. And that's what I wanted you to see there, because if I go back, take a look at this. There's the circular one when we did the reflection through the y = x line, was what we do for inverses. And when I do inverses, essentially what I'm doing here is I'm actually solving it for the y instead, and that's what I would end up with. So in the process of that, this is what we see. So now the clear upper function here is going to be the y = square root of 1 minus y squared. And what that means for us here with our integral, so our height being... So for this one, I'm going to have to give a volume defined here, because this problem didn't provide one for us. It talked about some average. But I'm going to find a different one. So let's come up with the f of xy equals, and we'll pick a cosine of x. That's what we'll pick for our f. So we're going to find the volume. So all right, find the volume. All right. So I had to change it up a little. So then our double integral, oops, let me give a little bit of space here. Is going to be from, now I'm going to pick the cosine x for my height, and I didn't have it in there. I apologize for that, guys. Now I'm going to do what first? So keep in mind these functions are in terms of x, and remember I have a further right function, so I'm looking at that change in x there. All right, that's what I'm looking for. Actually, let me go a little further so it's more representative. So it's going to go that whole distance, and that whole distance is my change in x. So that means I'm going to go dx first. And my upper function is going to be this one here, because that's the further right function. So I'm going to write the square root of 1 minus y squared. And then for the bottom function, that's this one here, that's going to be the lower function, and that's going to be -1 plus y squared. And then the bounds for the y next, because we have to do dy now, that's just going to be -1 to 1. So now we're all set up for our integral. And again, now we actually have a function above it so that we can talk about volume here. So that's what we're going to do now. So we're going to integrate this thing. So now we do the inner first. So that's where we're going to start. So the cosine of x then, and I'm assuming we're probably going to have to do part of this by hand and part of it by our calculator. We may not end up with some nasty numbers, so we'll have to play around with it as we go. So we're going to have the integral from -1 to 1, and then the derivative of cosine, or the integral of cosine, excuse me, is sine of x. So this is going to be the sine of x, which gives us a really easy integral here. But take a look at what we end up with now. And the square root of 1 minus y squared on top, dy, because we took the integral of cosine and that gave us the sine of x. So now we got to plug those values in, upper bound minus lower bound. So this is going to be an integral from -1 to 1 of the sine of x, not the sine of x anymore, excuse me, but the sine of the square root of 1 minus y squared minus the sine of -1 plus y squared. So upper bound minus lower bound doesn't change anything. Now this looks terrible. And I'll be honest with you, to integrate this by hand looks like it would probably make a grown man cry. Almost, not quite. So this one I'm going to do in my calculator here. I'm not going to do this one by hand. But the answer becomes, and I'll have to write approximately because I didn't get an exact answer, which I didn't expect that I would. At least with my calculator, I'm using a TI Inspired CAS CX or CX CAS. So anyways, this is a 2.5694441,321. And I'm just going to stop there. Actually, I'll just write the rest. I'm almost there. So that's what I ended up with for my volume there. And I knew this was going to be nasty because I picked the cosine of x. And one of my bounds was a square root function and squared function. That usually adds a level of complexity to do it by hand. But this is our answer for this one here. So that's it.